Hello, welcome to the second example here in factoring trinomials. These are quadratic trinomials, quadratic because the biggest power of x is x squared, and that's a quadratic term. This makes it a quadratic trinomial. Before we go on, however, I do want to go back to the example we did here in the previous video. Um, I guess I want to make sure that you make the connection that this original quadratic trinomial is equal to this factored trinomial or factored binomials. When I put the equals in between, that means they're the same. They're the same thing, right? When I multiply x plus 5 times x plus 4, I do get the same thing in a different form, and that's this answer called x squared plus 9x plus 20. It's kind of like saying 4 times 5 is 20. They're the same thing. And one way you can check that is this. If I put the original quadratic trinomial as a function into my calculator and graph it, and then if I put the other side, the factored version, and graph it, I should see the same thing if they are equal. And so I just want to show you that really quick, that if I take my calculator, I already put the original trinomial in y1. So I went to y equals, and I typed in the original trinomial. And then in y2, I put my factored version, my factors multiplying x plus 5 times x plus 4, because if this actually does give me x squared plus 9x plus 20, then I should see the same thing when I graph it. And so what I'm going to do is I'm going to graph the first one only. I'm going to graph the original x squared plus 9x plus 20, and if I graph it, it looks like this. It's a quadratic function. I see the parabola. Remember, we talked about the parabola being the name of the graph of a quadratic function. So this is what I see. But when I go back and I turn on this second thing, the second version, the factored version, watch what happens. When I graph it, it shades in the same graph because they're the same thing. And so that's one way you can check to see, hey, did I do my factoring correctly? It might take a little bit of time, putting the pressing all the buttons and putting everything in. But if you want to double check, x squared plus 9x plus 20, the original trinomial, is the same as x plus 5 times x plus 4. And I know that because when I graph them, they build the same graph, the same parabola. So that's one way we can check. The other thing I wanted to show you on the calculator, or I wanted to remind you on the calculator, is if you remember the example that we did, I was trying to find factors of 20 and say what times what gives me 20. Remember that we had used the calculator to figure out factors a long time ago. By a long time ago, I mean 2 months ago. So I'm going to clear this out, and I'm going to go to the home screen. If you ever want to know what times what are two numbers that give me a specific value, you can go to y equals, type in the value that you want. So I want to know what times what gives me 20, and divide by x. 20 divided by x. And now when you go to the table, it's going to list in the x and the y columns the two numbers. So when I go to the table, which is second graph, I'm going to see 1 times 20 is 20, 2 times 10 is 20, 3 times 6.6666666666666 is 20, but I don't want to deal with decimals. 4 times 5 is 20, 5 times 4 is 20, 6 times 3.3333333333, and I don't want to deal with decimals. So I'm going to skip all the decimals and just focus on the whole number pairs. So 1 times 20, 2 times 10, 4 times 5. But right here, notice that the numbers switched, and they're going to repeat, right? 5 times 4 is the same thing as 4 times 5. 10 times 2 is the same thing as 2 times 10. So you can figure out factors of numbers that way to figure out which ones you actually need. And so we're going to try that here when we do example number 2. So I'm going to try to factor 3x squared minus 11x minus 4. What does that mean? That means that I'm looking for two binomials, two things in parentheses, that when I multiply them, give me 3x squared minus 11x minus 4. In order to do that, I'm going to build a box, and I'm going to do 4 squares. In the first square, I'm going to write the first thing. In the last square, I'm going to write the last thing. In order to fill in the middle ones, I somehow need to separate or pull apart, or I don't know how to break up negative 11x or minus 11x. So the way to do that is to multiply. We're going to multiply these two numbers. So 3 times 4 is 12. And I want to know all the factors of 12. What times what gives me 12? Because I'm looking for the pair that when I subtract them, give me a negative 11. Okay, so I don't know how that's going to work, but let's figure it out. So I'm going to go to my calculator. I'm going to y equals. I'm going to clear it out. 12 divided by x. This is going to give me all the pairs of numbers that multiply to give me 12. If I press second graph, that'll take me to the table. Here's the first pair, 1 times 12, 2 times 6, 3 times 4. But then I notice it repeats and it just reverses it 4 times 3. And then I see 6 times 2 again, right? So really there's only 3 pairs, 1 and 12, 2 and 6, 3 and 4. So I'm going to write them down on my paper here. So 1, let me do them in green. 1 times 12, 2 times 6, 3 times 4, and that's it. But I'm looking for the pair that when I subtract the numbers, I get a negative 11 as my answer. Well, if I subtract 4 and 3, I'm either going to get positive 1 or negative 1. If I subtract 6 and 2, I'm going to get either positive 4 or negative 4. If I subtract 1 and 12, I'm either going to get positive 11 or negative 11, depending on the order that I subtract. So I think this is the actual pair that I want, but I have to do it in a special order. It has to be 1 minus 12 in order for it to give me negative 11. If I do 12 minus 1, I'm going to get positive 11. That's not what I want because that's not what's here. Okay, so now I know what the two numbers are. So I'm going to write them in here. Positive 1x and then minus 12. So minus 12x. These are the two terms that would give me the middle negative 11x. Great, now we're going to play our game. What do they have in common? What do these two terms have in common? What can I divide both of them by? I can divide both of them by x because both of them have a factor of x. Great. Now, x times what would give me 3x squared? Oh, well, x times x would give me x squared, but this has a 3, so I need a 3. So 3x times x would give me 3x squared. X times what is going to give me plus 1x? Well, oh no. Well, there you go. I think it's just 1x, right? Oh my gosh, I cannot erase that. Oh well. So this will be plus 1. X times 1 would give me plus 1x. Great. What times 3x would give me negative 12x? Well, what times 3 would give me negative 12? That would be minus 4. And if I did everything right, negative 4 times positive 1 is negative 4. I figured out my factoring. On the left side, I have x minus 4. On the top side, I have 3x plus 1. And just like that, I have my factoring. Is it correct? Did I do it correctly? Well, we can check. We can use our calculator to figure that out. How? By graphing it. 3x squared minus 11x minus 4. So I'm going to come to my calculator. 3x squared. I'm going to go up here to y equals 3x squared minus 11x minus 4. Okay. And then in the second line, I'm going to write what I think the factored version is, which is x minus 4, 3x plus 1. So I'm going to write x minus 4, 3x plus 1. And if I did everything correct, I should see the same graph. Here we go. There's one graph, and there's the other graph. They're the same graph because they're equivalent, they're equal, and I did the factoring correctly. This is my factor version. Factors are things that multiply to give me a value. Well, in this case, these two parentheses, x minus 4 and 3x plus 1, when I multiply them, will give me this answer of 3x squared minus 11x minus 4. But because they're equivalent, that means I can check them on my calculator to see if I'm doing things right.